YouTube. Again, all my video, I'm trying to start recording all my lessons also on YouTube so that you can have a recording of it. And so what we're trying to do is, let me explain our goal today. Is we want to understand what an orbital notation is and an electron configuration, and we want to be able to do both correctly. We also want to add how to do a noble gas configuration. It's like a shorthand way of doing electron configuration. We want to understand the order of our orbitals and how they fill, and that's according to the off-ball principle. And then we want to be able to do, again, a lot of electron configurations correctly. All right, and so what we're going to do first is we are going to do a simple electron configuration with orbital notation here. So I'm going to show you my screen. All right. All right, and I would encourage you to use the textbook today on 126 and 127. So that's what we're going to be using it quite a bit. So use your textbook a good bit today. All right, and so our first thing that we're going to do is all right, and so what we're doing is we're doing phosphorus electron configuration. Phosphorus is electron configuration. All right, and then we're also going to do phosphorus's orbital notation. All right, I'm going to pause the video, and while I pause the video, I'm going to give you about 2 minutes to do that. So you're going to take 2 minutes and pause the video and do these two problems here. All right, and so we were doing this, and it's going to be starting off. We're going to do a phosphorus has how many electrons? 15 electrons. And so I fill up my first level is 1s2, 2s2, 2p6, 3s2, and then I have 12 electrons, and I only have 15, so it'll be 3p3. All right, and this is for phosphorus. Okay. All right, now the orbital notation. All right. There's 1s, there's 2s, here is 2p, it's 3 orbitals for 2p. All right, then we have 3s, and then we have 3 orbitals for 3p. All right, and so we're going to fill up the orbitals. We have 15 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if on the last ones, they're all going to be pointing up, or they could all be pointing down. It doesn't matter. And so, but just all in separate orbitals. That's according to which rule is that when they all go in separate orbitals. Hund's rule. That's correct. Hund's rule is that rule where they all go in separate orbitals and they have the same spin. That's what the deal is here. All right. One thing we're going to also add right here is valence electrons. What are valence electrons? Do not shut it out. What are valence electrons? Titia. Yes, they're important for bonding and chemical reactions. All right, and so the highest energy level is typically the number with the highest number right here. So the highest energy level here is 3. And so how many total electrons are in this third energy level? 5. 5 electrons. So this has 5 valence electrons. Okay. And so that's how we got that right here. We are going to do another one. We're going to do bromine. All right. And I just want the electron configuration for bromine. All right, bromine. Bromine's electron configuration. That's not probably good writing, but that's okay. Let bromine's electron configuration. I'm going to give you about 2 minutes to do 1 to 2 minutes to do bromine's electron configuration. Pause the video if you're watching this, and I'm going to give you about 1.5 minutes. Do that. All right. Most everyone I saw got this correct. Ellie, help me with this here. Bromine has how many valence electrons? 35 electrons. All right. And so, not valence, it has 35 electrons. All right. And so that's 35 electrons. So the first ones fill 1s2. Then the next ones go to 2s2. Then the next one is 2p6. Then the next one is 3s2. Then 3p6. 4s2. Then 3d10. And then 4p5. The last sublevel is not full. It only has 5 electrons. All right. Now, how many valence electrons does bromine have? Again, you only add the ones in the highest energy level. So that would be how many? Right here, Kennedy. 7. This has 7 valence electrons because 2 plus 5 is equal to 7. On this last one, when we did 2 plus 3 because that was the highest level. So that made it 5. This had 5, phosphorus had 5 valence electrons. In fact, if we look at our periodic table, here's an easy way to memorize how many valence electrons. You will have this on your test. The valence electrons are the ones in the outermost energy level. All the elements in group 1 have 1 valence electron. All the elements in group 2 have 2 valence electrons. If I skip to 13, they have 3 valence electrons. 14 or 4A is 4 valence electrons. 5A or 15 is 5, 6, 7, and the last group is 8, with the exception of helium, which has 2. All right. Now, you might ask, what about these? And we're going to talk about these, but you wouldn't have to know that for the test quite yet. But again, the D group elements or the transition metals and the lanthanide and actinide series, you wouldn't have to know those quite as like how many valence electrons. All right, now we're going to do another one, another electron configuration. All right, and we're doing copper. All right, copper's electron configuration. Copper's electron configuration. All right, now copper is going to be a little funny. I'm going to tell you that. It's going to do something a little funny because I'll tell you why in just a minute. But you're going to do this one, and again, most of you will not get this one right. But do it as best you can, and the reason being because it's going to do something really funny. All right, and we'll explain it in just a moment. But try to do it right now. If you're watching the video, pause it for about 1 minute, 1.5 minutes, and then watch the video. And again, everybody except for 2 people got it wrong. All right, and the reason that's good, it's a teaching point. You would think that this is the correct answer. This is what you would think: 4s2, 3d9. But actually, the correct answer is the last 2 are 4s1, 3d10. Now, you might ask, why did it do that? All right, well, 3D, that's why we actually call these elements right here. We don't call them 4D, we call them 3D. All right, even though they're on the 4th period, we call them 3D because when they are getting close to full, instead of filling, just leaving this one short, it's going to bar from the S. And so it's going to make it 3D10, 4S1. It would do the same right here for chromium. Chromium has got 4. Instead of it being just 3D4, it would be actually 3D5, 4S1. All right. So again, it's going to, this is considered a lower energy level than 4S. All right. It's considered that's why they call it 3D. Okay. It's considered a lower energy level. And that same thing happens for not just copper, but for silver, gold, and this one's kind of a man-made element, but these elements do the same thing. They borrow one from the S sublevel. All right. And the same thing happens for chromium, molybdenum, and tungsten. They do borrow one from the S level. All right. And so because this is considered a lower energy level, because this would be, if you were doing this would be 6S, and this would be 5D. This is considered a lower energy level. And so we're learning about that. Ellie, you had a question? Yeah, these are all the ones in yellow, and it's actually going to do something similar in F, but I wouldn't test you on that. Okay. All right. One note, I want to remind us about how our filling levels, all right, our order of filling. Okay. And there are two ways to determine the order of filling. All right. And again, I like this first method right here, which is called the diagonal rule, to help me know my rules here. So again, there are two ways. There is this way, which is the diagonal rule, and I write all the S levels. And so on the test, if you are try having to do this, you won't have this. So you write out all your S levels. The next thing, you write down your P levels. And you might say, do I start my 2P up here? No, I start with the 2s. And I do 2P6, 3P6, because there's no 1P. There's no 1P6 here. 4P6, 5P6, 6P6, and 7P6. Then I do my Ds. The first D level is 3D10, 4D10, 5D10, and 6D10. There's no 7D10. And then my F, there's only two Fs, 4F14 and 5F14. All right. And the order of this is like this here. The order goes like this. It's called the diagonal rule. And the reason it's diagonal is because it tells the filling level, the electron, the orbitals, which orbitals fill, which are lowest energy. This is the lowest energy. This is the next lowest energy. This is the next lowest energy. This is the next lowest energy. Then I go to 4S. After 4S, the next lowest energy for most elements is 3D10. The next one is 4D10 after 5S. After 4D10, it's 5P6. After 5P6, it's 6S2. After 6S2, I go all the way back up and I do 4F14. Then I do 5D10. And so it's called my diagonal rule. And it tells the order that I fill, the order or the energy levels in which I fill first, the orbitals that I fill first, because the lowest energy orbitals fill first. Orbital fill level or order. All right, so that is the diagonal rule. And it's also, you can do the N plus L rule, which is the principal quantum number plus the shape quantum number, or the angular momentum quantum number. And the one that has the lower number will also fill first, unless they're tied. And if they're tied, you go to the lower principal quantum number, the lower principal quantum number. All right, and so I'm not going to go into that too much right now. Let's do another practice problem. All right, so we've done that. Let's do another one. All right, I'm going to build them up, and then let's stand together. All right, we're going to do, try to build you up. We're going to do molybdenum. Molybdenum. It's going to be Mo. All right, we're doing Mo, and you're going to do that one right here. I want you to do the electron. Molly, let me spell it right. BDNUN. All right. All right, and we want to do its electron configuration. All right, I'm coming around. I want you to pause. If you're watching this, you're going to pause the video for about 1 minute and do this problem. And all right. Randy, if you'll do the problem up here, I'm going to coach you through it. You won't have to, your face will not be in the video. So, all right, so here is a marker so you can do it here. All right. All right. So would you, first off, this is molybdenum, which its symbol is MO. So write MO if you would there. All right. And how many electrons is it out?
42.
42 electrons. So 42 electrons. All right. What level do they go into first? Yep. So write 1s squared. There you go. I like how you wrote right there. It's good for us. All right. What's next?
2s squared.
All right. What's next?
2p to the 6.
And what's next?
3s squared.
And the next?
3p to the 6.
Okay.
And then 4s squared.
And again, and when we follow these, again, this is our pathway. And so 4s squared, then 3d 10, then 4p 6. All right, is that squared? 5s, what is that?
1.
5s1, yes.
And then 4p.
All right, so, and the reason for that, is that this has 5, if we did the orbital notation, this would have 5 orbitals, okay? The 5 orbitals, just like that one right behind Omari has 5 orbitals, but that would give each one of those orbitals 1 electron in them. And that's considered lower energy because it's in the 4th energy level, whereas this is in the 5th energy level, all right? And so this would have 5 electrons, 1 in each orbital, and this would have 1, so it's bar. That's why we write it as 4d, because it's considered a lower energy for the elements in the transition metals. That is considered lower energy to fill, especially when it's on that borderline of between having 1 in every one or being full. Okay, very good. Good job. All right. All right, we're going to amp it up. Okay, it's time to amp it up. We got another one that we're going to do. All right, we're going to amp it up. All right, and so what we're going to amp it up to is this time. We are doing cerium. All right, cerium is, we're doing cerium's electron configuration. Cerium's electron configuration. All right. And I would tell you use the textbook, because again, it varies on here. Definitely use the textbook. This is why for this problem and some of these right here, this is why we use a textbook. All right. And the textbook periodic table is a little bit different. Cerium is right here. It's the first element on the ones that have, what is orbitals are these? These are considered the what orbitals? These were the D, the transition elements had the D levels. Their last electron was in the D, but these are considered the F, all right? And so we have we're having cerium, which has 1 electron in that F orbital, but look where it fits in. It fits in right here after lanthanum. Lanthanum. And so this is where these these are called the lanthanides because they follow lanthanum. All right, and they fit in right here. So this one's a little confusing, but I wanted you to try to do this. And so if you're watching the video at home, pause the video for just about a minute and a half, try this problem. And the good news is, again, no one got it right here. So let's look at this here. And why that's good news is that it means we all can learn. All right. Here is cerium's electron configuration. Okay. We go with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 4s2, 4d10, 5p6, 6s2. This is where it starts to get a little interesting here. 6s2 is right here. And then lanthanum is part of the D subset. It's part of the D, so that means it is 5d1. But then after lanthanum, there's a big gap. It goes from 57 to 72. Here is where cerium is, 58. And so that is part of the F series. And so the F sublevel. And so it's 5d1 for F1. And so if you look on here, I can look it up over here. All right, get out of the way. Get out of the way. All right, cerium's electron configuration. All right, and so you can see 6s2, 4f1, 5d1. Again, it didn't matter which way order you put those last two ends here. 6s2, 4f1, 5d1. As long as you had that, and you can kind of see that's what I had right here. All right, now again, that's why I'm telling you use the book, because if you use the one up over here on the period on the if you use the one over here, the problem is they have 15 elements right here. If you count for, they didn't put lanthanum. Lanthanum should probably be right here. All right, but they didn't put lanthanum with those. And so they have 15 elements. 15 elements can't fit in the F sublevel. Okay, the 15 electrons can't fit in that. So lanthanum would be considered right here. And other elements even have lutetium, and sometimes they have lutetium here. Again, that's why I like the textbook one, and I will give you a periodic table like this tomorrow for sure. Or you can look, I'm gonna take a picture and I'll put it on here. And so you can also have it on your Chromebook. Everyone's got a Chromebook and look it up. And you also can do that right here. So that's what I'm trying to give you with a little bit heads up there. All right, we're gonna do another one, and we're gonna do tungsten. Tungsten, atomic number 74. But recognize what happens in tungsten over here. Here's tungsten. All right, tungsten's there. And that means I go from 57 to 72. That mewhat are the elements from 57 to 72? Where are they located? The ones 58 through 71. Yeah, so that's the F subseries. So before I get to tungsten, I've got to fill this energy level up. In fact, I don't want to do tungsten. I'm going to do rhenium because there's a reason why. I have my own thinking. I might confuse you if I do. Well, we can do tungsten. Do rhenium, but do rhenium. Rhenium, and I have my reason because I don't want to screw you up. I'm trying to build you up. Remember, I tell you, take you down, and I build you back up. If we do tungsten, you might get a little discouraged. But instead, let's do rhenium, and let's build you up. Do rhenium because I want you to learn from that. I'm trying to break you down, build you up. Break you down, build you up. All right. Not trying to break you down. No. We're hopefully going to be building you up a lot. One more time here. So what we did here is the answer with rhenium. And this is what we call the note. And so rhenium is, again, it's going to be all this for rhenium. But what I wanted to show you is the noble gas configuration in addition before JJ comes up and does the problem for us. The noble gas configuration is a short way of doing electron configuration for elements with lots of electrons. And so what you do is you look at your last noble gas before rhenium. So here's rhenium. Here are the noble gases. So if I go backwards, the last one before I got to rhenium was xenon. So I'll write Xe, and then I do all the elements on the period that here. 6s2, then 4f14, and then 1, 2, 3, 4, 5, 5d5. And so that's how I get it. And these things are the same. Okay, these two are the same. All right. So if you would come up here, you're going to do this problem for us, JJ. You're going to teach us how to do rhenium. All right. You're going to teach us. And if you don't know how to do it, guess what? We're going to coach you through it. All right. So,
I have a question.
yes.
So like with 4F14, okay, this is how I did that. With 42 and 5, 9. With that.
No, that wouldn't work. That would not work. All right. All right. What's the symbol for rhenium? What's the symbol for rhenium? Re. That's correct. And do a little colon after it, if you would. All right. How many electrons does rhenium have? It has how many? I can see. Is that 65?
That's 75.
75. Okay. 75 electrons for rhenium. All right. So what's the first level that we're going to fill?
S.
1s2. Then what's next? You're doing great. Can you move it down a little bit so we can see here? Move this sheet down. There you go. Thank you. All right. 3s2, 3p6. Great. 4s2. All right. And again, if you're not sure what to do next, remember this is our order. So right after 4s2, I go to 3d10. 4p6. Excellent. 5s2. 4d10. 5p6. 6s2. Very good. Now you're going to do it again. If one thing is you're going to guess, you're going to do all the electrons for that here. Then you'll do 5d. How many electrons? How many is it over here? 1, 2, 3, 4, 5. So it's 5d5. That's exactly right. Now do the noble gas configuration for it. That was the last noble gas before it. It was. All right. Yep. All right, and so that's how to do this again. So it's not as bad as you think. All right, we're going to do one more. We're going to do one more as a class. All right, we're going to do one more as a class. Thank you, JJ. Good job. All right. All right. Here's the now. We're going to do uranium. All right. Uranium. All right. You're going to do uranium's electron configuration. All right. Uranium's electron configuration. All right. And again, you can do both the regular configuration and then you're going to do the noble gas configuration. So do both. I'm going to pause the video. I'm going to give about 3 minutes. All right. Uranium's electron configuration. All right. It's got 92 electrons, first off. So those are all this is the electron configuration. But the part that's probably the most interesting for you and me are these last ones. All right, and so to help us with the last ones, uranium is on this. This is on right here. There's uranium. It goes it goes in the 7th energy level. So that's 7s2. That's going to be 6d1. Then it goes over here to 1, 2, 3. And so that would be 5f3. 7s2, 6d1, 5f3. All right, that is uranium's noble gas configuration. And again, the reason I selected radon is because that's right before here. That's the last one right before we get to uranium. All right. One note here is, and again, if you don't believe me, you say, oh, man, that doesn't sound right. All right. So uranium. All right. F3, radon, F5F3, 6D1, 7S2, just like we were saying here. All right. And so that's what we're trying to show right here. 1 electron in the D subshell and 3 electrons in the 5F subshell. All right. So we're going to do one more. And I thought we were only going to do one more, but now we're going to do one more after this here. We're going to do gold. Gold. We'll do gold, AU. All right. I need you to do the just do the noble gas configuration for gold. Just the noble gas, because I want us to do one more thing before we stop for the day. So I'm gonna pause the video and do the noble gas configuration for gold. We are going to share our answer here. And so with this one, the gold has an atomic number of 79. So here is gold. Let me go back to this. Gold is right here, 79. The last noble gas before gold is xenon. Okay, the last noble gas before gold is xenon. All right, here's gold. The last noble gas is xenon. So I'm gonna write xenon Xe, and then I'm going to do 6s2. All right. And then I'm going to do, before I do all the ones all the way next to gold, and you're going to actually say there's a problem. I did 6s2. It's actually not going to be 6s2. It's going to be 6s1. All right. It's going to be 6s1, 4f14, 5d10. All right. Reason being, this one is so close to being full, so it takes one of the electrons from the higher energy level, the S. And so it becomes 6s1, 4f14, 5d10. All right, 5d10. All right. And again, if you don't believe me, again, we can look it up and we can see that that is the case here. All right, I want you to do your homework. Get your homework. Start working on your homework. Your homework looks like this. This was the homework we did the other day. This is what the homework we did the other day. I want you to do, starting on this side, do bromine, barium, and neptunium. Do those first. All right, bromine, barium, and neptunium. You're going to do both sides, front and back, tonight. That's your homework.